So lesson 3.2, properties of parallel lines. Okay. Now, what are parallel lines? Two lines that, well, let me ask you this. Can we, if we're talking about parallel lines, are we restricted just to 2 lines?
No.
Or can we say 10 lines? Yeah. So look at my ceiling. So if I'm looking at the tiles that are connected, okay, the line that goes from the front of my room to the back of my room, there's probably 10 or more, or more than 10. But anyway, all of those lines are parallel, right? Because they never intersect. So parallel lines, you can have more than 2 lines, but more specifically in this lesson, we're just going to look at 2 parallel lines and either 1 transversal or 2 transversals, okay? And you can have more than 2 transversals, okay? So postulate 3.1, okay? Same side interior angles postulate, okay? Same side interior angles. So the angles that lie within the 2 parallel lines, and are they on the same side or opposite side of the transversal? Same side, hence the name same side interior angles, okay? So if you read the postulate, it says, if a transversal intersects 2 parallel lines, then same side interior angles are supplementary, okay? So that is our first postulate. So I'm going to come over here, and we have same side interior angles. And we said that they are what? And what does supplementary mean? They have a sum.
180.
Very good. So 2 angles who have a sum of 180 degrees. All right? All right, so if you look at our diagram, okay, do y'all remember what this notation is right here? No. This notation right here? Parallel. So what we're saying here is that lines L and line M are parallel, okay? So they're parallel, and we have our transversal right here. And what are our same side interior angles? Okay, so we have angle 4 and angle 5 and angles, what'd you say? 3 and angle 6. Okay, so those are our same side interior angles. If they are same side interior angles, our postulate tells us that they are what?
Same side.
Right, but same side interior angles are supplementary. So what that means is I could add angle 4, or the measure of angle 4, plus the measure of angle 5, and get what? 180. And I could add the measure of angle 3 and the measure of angle 6 and get 180 as well. So same side interior angles are supplementary, okay? They are supplementary. All right, now let's look at this diagram right over here. So my exterior angles are 1, 6, 4, and 7, and my interior angles are 2, 5, 3, and 8. All right. So I'm going to move over to where the questions are asking. So it says the measure of angle 3 is 55 degrees. Which angles are supplementary to angle 3? How do you know? Okay. So by definition, a straight angle measures what? 180. Okay. And 180, this is how we'll be able to find the degrees of the other angles that are supplementary to angle 3. you would subtract 180 minus 55, and you get 125. Okay? So any angle at x where the measure of x equals 125 is supplementary to what angle? Angle 3. We're talking about angle 3. But yes, you're exactly right. So angle 8 has a measure of what? Not 55. 125. Okay, because it is supplementary. Now, here's what's crazy about these problems. I'm not going to write these down, but we're just going to talk about it because in the next few examples, we're going to look at it, okay? So what I can do is I'm given one angle with a degree, okay? And that's angle 3. And with one angle, I can name the measure of all of these angles with the postulates that we're going to learn today, okay? Does that make sense? So we're going to learn that we can name all of this with just one degree. All right? And then it says, if you know the measure of one of the angles, can you always find the measure of all 8 angles when 2 parallel lines are cut by transversal? Try it with example from part 1. That is a yes. And we're going to do an example here in a minute. We're going to do an example here in a minute. So yes, we can. One angle. That's all we need. Give me one, baby. Give me one. All right. So let's move on to theorem 3.1. Alternate interior angles theorem. So alternate interior angles theorem states that if a transversal intersects 2 what kind of lines? 2 parallel lines, then alternate interior angles are, and what does congruent mean? Okay, they are the same. So I'm going to go over here, and I'm going to write alternate interior angles. Ooh. And we said that they are? And by congruent, we mean that they have the same degree, same measure. All right? So looking at the diagram, okay, if L and M are parallel, if these 2 lines are parallel and it's cut by a transversal, what are my alternate interior angles? 4 and 6, and what else?
35.
All right. Since they are congruent, they have the same measure, correct? So we could say the measure of angle 4 is equal to the measure of angle 6, and the measure of angle 3 is equal to the measure of angle 5. Or we can say that angle 4 is congruent to angle 6, and angle 3 is congruent to angle 5. All right? So when you use the M notation, you're saying that the degrees, the measurement of that angle are equal. But if you use the congruency sign, you're saying that those 2 angles are congruent. Both of these are correct, and I'm not peculiar either way. If you say angle 4 equals angle 6, well, we know that congruent means equal, so you're good. Okay? Don't worry about notation, all right? I'm not picky. I'm not picky. As long as you understand the concept, I don't care. You can write out angle 4 equals angle 6, and you're going to get it right. I promise you that. All right? Anybody have any questions so far? Corresponding angles theorem. Okay, corresponding angles theorem. If a transversal intersects 2 parallel lines, then corresponding angles are what? Congruent. knocking it down, making it shake, making it shake. So, corresponding angles are congruent. So looking at the diagram, what are all my corresponding angles? Corresponding, what are they?
1 and 5.
Okay.
2 and 6.
Good.
Yeah,
4 and 8.
3 and 7.
Awesome. Very good. 3 and 7. Okay. And we said that all of these angles are what? Congruent. So we could say angle 1 is congruent to angle 5. Angle 2 is congruent to angle 6. Angle 3 is congruent to what angle?
7.
Good. And angle 4 is congruent to angle 8. All right. We want to prove that angle 1 and angle 8 are supplementary. Okay? We want to prove that angle 1 and angle 8 are supplementary. So what is given to us?
A is parallel to B.
Okay, so A is parallel to B. And the reason is because it is given. All right, it is given. In 2, okay, what do we know about angles 1 and angle 5? What type of angles are they? Are they corresponding, alternate exterior, alternate interior, or same side interior? They're corresponding. Okay? And corresponding angles are what? So we could say that angle 1 and angle 5 are congruent. And the reason is because corresponding angles are what? Congruent. So if angle 1 and angle 5 are congruent, then the measure of angle 1 is equal to the measure of angle 5. And the reason for that is congruent angles have the same measure. Right? We know that. It's pretty simple, right? So, what about angles 5 and 8? They're not corresponding, they're not alternate exterior, they're not alternate interior, and they're not same side interior. But those two angles together form a what? Not a parallel. Look right here. Okay? Think about what the word supplementary means. So if angle 5 and angle 8 were put together, then we'd have this straight line right here, right? And a straight line has a degree of 180. And supplementary angles have a sum of, so these two angles are supplementary. Very good. So we can say angle 5 and angle 8 are supplementary. And that's because that's the definition of supplementary angles. Okay? Now, if they are supplementary, then the measure of angle 5 plus the measure of angle 8 equals what? 180. And the reason being is the same thing. That's the definition of supplementary angles. Okay? And what angle did we say was congruent to angle 5? 1. So if they're congruent, that means that they are equal. So no matter what, we can substitute these two angles, and we could say that the measure of angle 1 plus the measure of angle 8 equals 180. Y'all agree with that? So let's say angle 5 is 60, or it'll be bigger than 60. Let's say 120. Angle 5 is 120. Angle 8 is 60. If 1 and 5 are congruent, then angle 1 has a degree of 120. So we still could add 120 plus 60 and get 180. Okay? And that is what we call the substitution property. So we could say that angle 1 and angle 8 are supplementary. And the reason, well, it's just the definition of supplementary angles. All right, so alternate exterior angles theorem. Okay? Somebody read that theorem to me. Taj, read that theorem to me.
I can't really see it.
Oh, now you can't see?
I mean, I can see, but I can't.
But don't you have it on your paper?
Oh, yeah, you're right.
Yeah, I know.
If a transversal intersects two parallel lines, then alternate exterior angles are proven.
They're congruent. So let's go to our wall over here and write alternate exterior angles are what? Awesome. So now we have learned every single theorem for these types of angles. Okay? So what we're going to do is flip over to the next page and look at the diagram. Where'd it go? There we go. So, what are my alternate exterior angles now? Angles 1 and 8 and 2. Oh, sorry, not 1 and 8. 1 and 7 and 2 and 8. And since they are congruent, we could say that angle 1 is congruent to angle 7, and angle 2 is congruent to angle 8. Capiche? All right.